Hello, I'm Juan Salmerón from UPC. We are going to see a demo from the task 4.3 Backplane API. On the figure number 1, we can see how all the systems on the Backplane API have their own use cases that are specified on the OpenAPI specification file. With an automatized procedures, we are aggregating all those OpenAPI specification files into a single one. On the figures number 2, we can see how when a client access to the service that are on the Backplane API, the data are traveling between the service and the client through the Backplane API. There are authenticated and unauthenticated methods of those services, and if there is an authentication one, it will be performed with an external authentication method that is an OpenID provider. On the next demo, we are going to see an example using the auditable accounting use case.
Well, we're going to see a demo of this model. As you can see here, this is the structure of the auditable accounting. Essentially, it's a model that receives blockchain registries, but we don't directly store these registries on the blockchain because this will cause a lot of data being registered. So what we're going to do is to aggregate all these registries. So each registry that we receive, we store it in our distributed storage, and then from time to time we aggregate all these registries, in particular using a Merkle hash tree, and then we register the root of this hash tree on the blockchain. And then we provide all the individual registration proofs, also known as Merkle proofs. We compute the Merkle proofs for each registry and also store these on the database, on the distributed storage. And then after that, via API, you can also ask for a particular registration and its corresponding proof. We will see that in a moment in a demo.
The Backplane API is integrating several services that each one has their own endpoints or features or use cases. And here we can see the specification of the use cases available for the auditable accounting service. Here we have the registry blockchain controller and the registry controller, and then as the other services are integrated inside the Backplane API services. We can see here that we have the ones that we have on the auditable accounting under the auditable accounting slash and the use cases, and we have also the other use cases of other services available on the Backplane API. So what are we going to see here is that when we interact with the use cases of the auditable accounting, we can see here on the left side on the terminal that we see a redirection to that service. So the request is going from the BackplaneAPIGateway to the service. So let's see a little demo in order to see that behavior.
Okay, thank you, Juan. To start the demo with the auditable accounting, we can see here two controllers: the registry blockchain, which is responsible to manage the smart contract, and the registry controller, which is responsible to receive the data and manage it, storing it in a database. To make the demo, the first thing to do is to post some new registry, and store it on the database. To do that, we call the endpoint registries with a post option, and we can set here any string to be stored. In that case, it should be, in a real case, should be a hash, but here we can set anything to show. We execute this endpoint, and we see here that everything it's correct, and we receive an ID that we later will use to get the registry with the correct data. Let's add another one to prepare the new transaction. Again. Okay, we can see here the ID is updated. At any point, we can check the current state of the registries. If we go to the other endpoint to get registries ID, and we try it out with one of the previous IDs to receive the previous stored data with everything null because it's not computed yet. Then at this point we have the registries stored on the database but not on the blockchain. To do that, we have to go to the other controller, the registry blockchain controller, and here we have three endpoints. The first one, the calculate maker rule, is to compute the new transaction and prepare the new registries to be audited on the blockchain, but not generate the transaction to the blockchain. If we try it out, we can execute, and we see here the new transaction with the Merkle root that ends with C89. To do that, the next step is to send to the blockchain to the update registries, which will generate a new transaction, and our i3 market network will generate a new block each minute. If we go to the Explorer, we will see a new transaction in a few seconds. Okay, as you see, is a new block generated. You go into the block, you will see just one transaction, and if we go into the transaction, we will see it's generated from the data accounting address, and in the input data, it will contain the new root. But to check that, we can return to the API and execute the last endpoint, the get current root, which connects to the smart contract and receive the current root stored on them. And as you see, is the C89 that we compute previously. That means that the new registries included in this demo are correctly audited from this component.